Solved problems. Which assignments satisfy the atomic formula P0X in this unary structure? So the unary structure has two unary predicates P0 and P1. And then there are elements all over the structure, and we are given three assignments S0, S1 and S2. To decide whether an assignment satisfies the atomic formula P0X, we should look at the value of X on that assignment. For these assignments S0, S1, S2, the value of X is B, C or G. So we should look at whether the elements B, C and G are in P0 or not. The picture clearly indicates that B and C are in P0 and G is not. So the answer is assignments S0 and S1 satisfy the atomic formula P0X since S0X equals B and S1X equals C, and they are both in the set P0M. Assignment S2 does not satisfy the atomic formula P0X since S2X is G and G is not in the set P0M. Which assignment satisfies the atomic formula P2Z in this unary structure? We are given a unary structure with three unary predicates P2, P3 and P5. And we are given three assignments S0, S1 and S2. Since the formula we are looking at is P2Z, we should look at the value of Z in these assignments. The table shows that the value of Z is 5 or 0 or 6. And then we should contemplate whether this element is in P2. The picture shows that 5 is not, 0 is not in P2M, and 6 is not in P2M. So the answer is none of the assignments satisfy the atomic formula P2Z since no value of Z is in the set P2M. Which assignments satisfy the formula P1X in this unary structure? In this unary structure we have two unary predicates P0 and P1, and then some elements that have been indicated. In this unary structure P0 seems to be completely contained in P1. Anyway, we should look at the value of X in the given assignments S0, S1 and S2. The value of X is C, A and then an S2, E. So let's look at the picture. Are the elements C, A and E in P1M? C seems to be there, A seems to be there, but E seems to be outside P1M. So the answer is S0 satisfies, S1 satisfies, but S2 does not satisfy. Which assignments satisfy the formula XEY in the given graph? So the graph has 5 vertices and 5 edges. And we are given 3 assignments. So to decide whether this binary predicate is satisfied by an assignment, we should look at the values of X and Y. So for each assignment, S0, S1 and S2, we look at the value they give to X and Y, and then we check whether there's an edge between the values. For S0, the value of X is 4 and the value of Y is 5. Indeed, there is an edge between 4 and 5, so the answer is yes. For S1, the value of x and y is the same element 1, in a graph there is never an edge between a vertex and itself, so the answer is no. In S2 the value of x is 1 and the value of y is 2. Between 1 and 2 there could be an edge, but there isn't, so the answer is no. Which assignments satisfy the formula ZEY in this graph? Again, the graph has 5 vertices and 5 edges, and we are given 3 assignments. Let's look at the values of Z and Y. In S0, Z and Y are both 1, so there couldn't possibly be an edge. We know that even without looking at the graph, so the answer is no. For S1, the value of Z is 3 and the value of Y is 5. Between 3 and 5 there is an edge, so the answer is yes. S2, the value of Z is 4, the value of Y is 2, no edge, so the answer is no. Give in each case a unary structure and one assignment that satisfies a formula and one that does not. And the given formulas are 1 P0x, 2 P1y, 3 P1z, and 4 P2x. So the vocabulary here seems to consist of 3 unary predicates P0, P1 and P2. Let's build a unary structure with 3 unary predicates P0, P1 and P2, and in this picture we have made it rather generic, so there are all kinds of elements, and hopefully with this one structure we can satisfy all our needs. So now we need 4 assignments which satisfy these formulas, and then 4 others that don't satisfy. Here are the 4 assignments that satisfy the formula. Let's look at S1. The value of x is 1 and 1 is in P0 M, so the first formula is satisfied by S1. Let's look at S2. The value of y is 6 and 6 is in P1M, so S2 does satisfy the formula P1y. Then S3, does it satisfy the third formula P1z? The value of z in S3 is 6 and 6 is in P1M, so S3 does satisfy the formula P1z. Finally S4, we check whether it satisfies the fourth formula P2x. The value of x in S4 is 3, and when we look at the picture, indeed 3 is in P2. So S4 does satisfy the formula P2x. And here are 4 assignments that do not satisfy these formulas. So S1 does not satisfy the first formula P0x, because the value of x in S1 is now 6 and 6 is not in the set P0M. For the second formula P1y we have S2, which maps the variable y to 3, and 3 is not in the set P1M. So S2 does not satisfy P1y. Let's look at the third formula P1z and the third assignment S3. The value of z in S3 is 2, and 2 indeed is outside the set P1M. So S3 does not satisfy P1z. Finally S4 maps x to 1, and the element 1 in this model is outside the set P2M, so S4 does not satisfy the formula P2x. And we are done.